Hello again. As you know, I am Eli, the computer guy. Today we're going to be talking about network convergence introduction. And hopefully we will not have any audio problems. It is a very windy day outside, but hopefully, since I've got my fancy little shotgun microphone here, you shouldn't notice all of the wind and all of the creaky. We shall see. We shall see. But today we're going to be talking about network convergence. So this is a huge issue in the modern world. This is something that started somewhere between 10 to 15 years ago, but is now in full swing. And if you do not understand what network convergence is and the issues that you may run into, it could cause you a lot of problems going into the future. So basically, the underlying idea of what network convergence is this is where all types of different technology systems are being changed and migrated so that they work on TCP/IP networks. So instead of working on their own dedicated infrastructure the way they used to with CCTV or with telephone systems or with access control, where they use their own protocols, they use their own physical media to connect to different types of servers and that type of thing. Now all of these different types of electronic devices are now using TCP/IP, and they're using Ethernet, and they're using Wi-Fi in order to use the infrastructure that's already been built for your PC server network and to allow communication between all of these devices. This is absolutely a great thing, but it can run into a few problems, and that is what we are going to be talking about today. Now, before we get into the class, of course, we always have to talk about our sponsors, because the sponsors are the ones that help pay the bills. Gilware, Data Recovery and Backup Solutions. Gilware's partner programs help computer repair and IT professionals make money by offering data recovery and backup services to their customers. Take a look at Gilware.com. Spiceworks, the best online community for IT professionals to help solve your tech problems. Community.spiceworks.com. And finally, Schoolie Mitchell. Schoolie Mitchell's purpose is to increase clients' profit by reducing telecom cost using software and processes at no risk. We only share savings. SchoolieMitchell.com. And as I say, don't subscribe, don't thumb up, don't leave a comment, but darn it, click those links below. That's all I'm asking you to do. That's all I want out of you, really, I swear. So let's start talking about convergence. So back in the day, back in the old days, back in 2000 when I was a young man, we had these things called silos, right? And basically all different types of technology in your infrastructure used their own infrastructure. They used their own technology to communicate. So when you had surveillance systems, CCTV systems, when you had telephone systems, when you had PCs, when you had access control, they used their own infrastructure. Actually, that VoIP is wrong. Now that I look at that, VoIP should just say telephone. VoIP is converged. Telephone is before VoIP. So you'd have surveillance systems, you'd have telephone systems, you had your PC systems, and you had your access control systems. Now, when we talk about things being siloed, again, all of these use their own media, they use their own protocols, they use their own ways of communicating. So if you looked at surveillance systems, right? Surveillance systems used basically coax cable, the coax cable that runs to your cable box if you haven't cut your cable yet. So the surveillance systems used coax cable with a power line connected to it. So it used to be called Siamese cable. So basically what you would have is you would have a box that would be considered your DVR or your surveillance system. On the back of it, it had BNC connectors. And so you would connect the coax cable to the BNC connectors that would run out to your cameras, and it was its own dedicated infrastructure. So basically it used coax cable, it used power lines, it was its own thing. It even used its own protocol. So the communication between the camera and the surveillance server, either a digital video recorder or whatever CCTV system, that was analog. So going over coax, that was analog. And then if you use something like a PTZ, a pan tilt zoom camera, so like one of those robotic cameras. Oh my golly, you had to use this Pelco protocol. Oh, none of you people ever complain about TCP/IP. Oh, Pelco D. Oh, 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 oh. I just look at my face. Pelco sucked. Right? But basically, the underlying thing is it used all of its own equipment, it used all of its own protocols. You want to go over to the telephone system. Again, telephone, not VoIP. I made a mistake here. Eli, the computer guy, made a mistake on a slide. Instead of VoIP, this should be telephone. And so telephone, you had the normal telephones that connected back to something called a PBX. PBX would also have some kind of voicemail system connected to it. And the telephones connected to the PBX using either analog or digital lines. A lot of times, this was Cat 3 lines. You may hear of you hear of Cat 3, Cat 5, Cat 5e, Cat 6. These are different network cables. So a lot of times you'd use Cat 3 lines for the telephone system. Basically, so you'd have the telephones, which were either digital or analog, not TCP/IP, digital or analog. They would connect back to a PBX. The PBX would then connect to your POTS, your plain old telephone system lines. And in order to connect to that, you had this thin little wire that connected to either a 110 or a 66 block. Again, if all you know is TCP/IP and Ethernet, all the stuff I'm talking about doesn't mean anything to you. But this is the type of equipment they use for telephone systems. Then, of course, you had the PC systems, PCs, servers that used Cat5 cable, that use DNS and DHCP and servers and all that kind of stuff that you're used to. And then you also have access control. And many businesses, access control is where you have some kind of a badge and you flip it over a little access control thing on the wall, and that opens up a door, right? And that uses low power, and it uses its own thing. So basically, the big issue to understand here, in the old days, these were all siloed. So you ran coax cable for your surveillance systems, you ran Cat 3 cable for your telephone systems, you ran Cat 5 cable for your PCs, and basically you ran this low power stuff for your access control. So they may connect. Now you may think of this, you may think, well, Eli, back in 2000, a DVR, a digital video recorder, I was able to look at that online. I was able to look at on that on the internet. Doesn't that mean it was converged? No, and the reason being is because all the individual devices could only communicate within the silo. Now, the server, that digital video recorder, that may have had a network connection that allowed you to access it from the outside world, but it was still siloed. It was still its own deal. And there's some benefits to this. There are actually some benefits to doing it this way, but there were a lot of problems. The big problem with an infrastructure like this is, frankly, you have to have different infrastructure for every type of equipment that you're going to use. You can't simply run 4 Cat 5 cables and figure you can connect whatever the hell you want to it. Again, you've got to have your own dedicated infrastructures with their own quirks, with their own problems, with their own all that kind of stuff. So the idea of convergence is what we're trying to do, and what we've been doing for the past 10 or 15 years is, instead of having multiple silos, we now have the one single silo. We are converging all the silos into one single silo. So we're breaking down the silos. What does that mean? So now it means with your surveillance system and your telephone system and your access control system, you're not using all of those different types of cabling that we used before. Now we are using Ethernet, 5e, Cat 6, 802.11 if we're doing wireless. So basically that transport medium is now the same across the board. We're now using TCP/IP for the protocol. So again, if anybody ever dealt with Pelco D, oh, that was brutal, right? So instead of dealing with Pelco D or any of that kind of stuff, we're using TCP/IP. You can create little apps or whatever in order to move your pan tilt zoom cameras around. You're not dealing with all these different protocols that you were before. You're also using shared services, so things like DNS, things like DHCP. All of these different devices can use the same services that are being provided on the network. Now, this is a good thing in a lot of ways. In a lot of ways, this is an absolutely amazing thing. The biggest reason this is an amazing thing is basically you don't have to run multiple types of cable all over a building, right? Because that used to be a problem back in the day, like with telephone lines, or with access control, or with surveillance system lines. The thing is, you had to have what are called home runs. So you have a camera, and the line, the cable that goes from the camera has to go directly back to the surveillance system. It can't go through switches, it can't get routed, it can't do any of that kind of stuff, right? So if you have a big warehouse, and believe me, when you go out there into the real business world, you will be shocked how big some warehouses are. Really big warehouses, thousands of feet, down the line. So here's the problem, right? So let's say, thousands of feet, somebody goes in, you install a 12 camera surveillance system, right? So when you install the surveillance system, the owner of the company says, we want cameras positioned so we can see all the different trucks that are in the dock. We want surveillance cameras to show what's going on inside. And so basically you do all of these different surveillance cameras, right? And how it always goes is there was never an office in the middle of the building. Especially like with these warehouses. It'd be so nice if the office was in the middle of the building. Most of the time, like the office, for whatever reason, is on either side. Right? You don't think about it, no big deal. So you go in there, you run all this cable, you make some really good money. Oh, back in the days of running cable, really good money, and you go home as far as the business is concerned. But then the problem comes up is, as with everything, right? Whenever a business owner or a CEO specs a project or plans a project, they deploy the project, and then they realize, there's something they missed, right? So you put up all these surveillance cameras, you do it how you think you want to do it, all the cameras are in position, but here's the thing, there's one side of the building that doesn't have any doors on it, it doesn't have any windows on it, it doesn't have any trucks parking into it, it's just grass, right? It's just grass. And so when you install the surveillance system, the CEO or the boss said, don't worry about that. It doesn't matter. There's literally nothing valuable on that side of the building. I don't want that side of the building surveilled. Okay, so you line them up. And then a month later, you get a call from the boss or the CEO saying, we need to get a camera on the side of the building. And you're sitting there and you're like, why? Did I miss something? There's not a door there. There's not access control. There's not there's not trucks. There's not even a drive-through. Like, why do you need a camera now? And it's like, we just started having these crackheads start using drugs there at 2 o'clock in the morning. So I need to have a surveillance camera there to show that this is happening, to be able to give that to the police, for the police to be able to deal with it. And again, having people do drugs in your property is a real issue that businesses have to deal with. Well, here's the problem. You already went in and you ran all of those cables, right? And so you have your office here. And in order to install the camera all the way on the other side, because it's always going to be on the other side, that means you have to run a direct cable from that camera you install all the way back to the main office. And that can be a long way, a long way, right? And that's the problem in that old siloed infrastructure, is you had to have those direct runs. Now, if you have a converged infrastructure, so now you're dealing with IP cameras instead of the old CCTV cameras, what you can do is you can simply have a switch on that side of the building. So basically, if you have two sides of the building, you have your main server room and everything here. You run one Cat6 cable all the way over to the other side of the building. You drop that into a switch. And now if you need to add any other devices on that side of the building, you can now run a 15-foot run or a 20-foot run or a 50-foot run. You don't have to run a 1,000-foot run, right? So basically you can have that one cable that goes over, you drop that into a switch. If you need telephones over there, you can simply plug it in. If you need a new surveillance camera over there, you can simply plug it in. If you need any of this stuff over there. So basically the idea is that you can use that one single infrastructure and it makes it a lot easier. Again, one of the things that you have to be thinking about from a business standpoint is that when you build out an infrastructure, that you always have to over-provision. So this is one of the reasons, like when you go into an office, you'll notice like many times in the wall for network cabling, there will be like 3 or 4 ports on like every wall. So there will be like 2 or 3 ports here and 2 or 3 ports here and 2 or 3 ports here and 2 or 3 ports here. The reason is because when the office was being built out, the people who were building out the office didn't know where the desk would go. Would the desk go on this wall, or would it go on this wall, or go on this wall? or this wall? You don't know. Like, or are there going to be 2 desks in the same room? Or are you going to be some poor bastard working in a room with 3 desks? And so they wanted the ability, that flexibility, going into the future. So you over provision. Well, here's the thing: if your telephone lines are using, if your telephone system is using one type of cable and your network system is using a different type of cable, that means you have to do more runs. So every single one of those wall outlets has to have its own telephone cable going to it, at least one, maybe 2, and then it also needs a network cable. So instead of now, if you have convergence, if you have everything using Ethernet, instead of doing, let's say, 2 network ports to each wall plus 1 or 2 telephone cables, now you can just run 2 network ports. If you can reduce 4 network drops per room and you have 20 rooms, that's a lot. 80 drops, right, by doing convergence. Why that becomes valuable is, at least back in the day when we charged, then the normal fee, it was about $150 per run, per drop. So every port you see on the wall, every port, not every patch panel, every port on that patch panel that's live, that's usable, was $150. So if you figure, 80 runs that you can save times $150, 8,000, somewhere along the lines of $12,000 you can save just simply by migrating your telephone system over to being a voice over IP telephone system versus the old type of telephone system. So this is why convergence is so valuable. Building things out in the future, it makes it a lot more valuable, dealing with build out and all that kind of stuff. Beyond that, what's really nice is once you have a converged infrastructure, all of your different devices can now communicate with one another. So back in the old days, if you had a telephone system, the telephone system only talked to the telephone system. And your Exchange server only talked with the PCs. Now here's the problem. If you want to create, like, say, an Office directory, if you want to create some kind of like speed dial Office directory, that means you have to manually or go through some process of creating that for the PBX in the old siloed world. So you have your telephone system and you're like, right? We've got all of these, we've got this whole Office directory, we've got all this information in the Exchange server, but we can't just take the information from the Exchange server and put it into the PBX. Doesn't work that way. Well, what's really cool now is when you have voice over IP telephones, you can actually have them connect to the Exchange server. So they can actually connect into the Exchange server. Once they've connected into the Exchange server, they can now see things like phone numbers and all that kind of stuff. And so instead of everybody having to have their own Rolodex or manually input information into the PBX or whatever, when somebody needs to dial the CEO or somebody needs to dial the secretary, they can actually just pull that up on their telephone and be able to call. Other things that are valuable is things like if you have a surveillance camera and it's able to like detect some kind of movement in a place there shouldn't be movement, it can now automatically be able to email out or send an SMS message out to whoever should be told about that. So the thing is, with all of these systems being able to be put onto the same infrastructure, it gives you a lot of ability. It decreases the cost of infrastructure a massive amount. Plus, all of these devices can now communicate to each other in new and interesting ways. You see this a lot. Like if you look at Axis surveillance cameras, if you look at some of these new services, voice over IP services, surveillance cameras, they actually have their own APIs. So if you're in a real enterprise environment where you actually have your own development department to program things, what that means is you can now actually create your own software in your company to be able to pull from all of these different types of resources and be able to do some really cool stuff. So that is why convergence is really important. Now, if you're going to be going over to a converged world, there is planning that you have to do. Right? Everybody always goes, yay! Saves money, gives me options, good. Let's do it now. But there are some things that you have to be thinking about before you go over to a converged world. The first thing is network capacity. right? How much capacity does your network have? Because the issue is when you have your old PC, your client server architecture, with that, if all you're doing is sending emails and all you're doing is browsing web pages and all that kind of stuff, that really doesn't require very much bandwidth, like ever. Ever, 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 right? So if you installed, Cisco 10100 switches, literally back in like 1999, the chances are your switches are still doing fine for simply doing PC stuff, right? PC server, maybe it gets slow every once in a while, but usually if it gets a little slow, it's one of those things where you go, that seems a little slow. And then it's back to doing what it's doing. You're like, right? It doesn't really matter. So one of the things you have to be thinking about is if you're going to start having voice over IP traffic on your network, if you're going to start having surveillance video over your network, if you're going to start having this access control stuff over your network, most likely if you have an old network, you're going to need to upgrade your internal network, preferably up to gigabit per second switches, gigabit per second networking, to make sure that it can handle all of this new traffic that's going over the network. Because, if you start putting out high definition video, like 5 megapixel or 10 megapixel surveillance cameras, they can push out a lot of data. And again, with everything, something that a lot of people don't think about is if you put one high definition video camera on your network and you got a 10100 switch, what does it matter? Yeah, right. Eli, you're just worrying. You're just worried. But again, most people don't put one, right? They put 10 or they put 20, and you put 20 high definition, 5 megapixel and above video cameras on your network, pumping data back to what's called an NVR, a network video recorder, and you can saturate your entire network with that traffic if it's a 10100 network in a heartbeat. So you really have to think about your network capacity and then also your ISP capacity. So with your ISP service, you've got to be looking at it and look at what datacom plan that you currently have. Again, a lot of us laugh at it. A T1 line, 1.5 megabit per second connections. It's the modern world. Who the hell would have that? But on the other hand, you know what? If all you're doing is pushing and pulling email, and browsing basically text-based websites for an office of 10 or 20 people, a T1 line, it probably works okay, right? You got your service level agreement. You have 1.5 megabits per second 99.99999% of the time, right? And so maybe that's been good enough. Well, now if you put voice over IP onto your network, and especially if you're going out, you're actually sending that voice over IP traffic out onto to the internet in order to communicate with the outside world. Now you got to start looking again. You got 5, 10, 20 people. How many people are going to be on a voice call at any one time, and what happens with convergence, especially with the internet connection? I saw this happen after I put in a surveillance system for one company. So I was told, again, this is one of those things, again, real life lessons, where you really have to make sure the people that you're buying your product know what the hell they're talking about. So I went in and we installed a surveillance system, and they had the ability to remotely monitor the surveillance system. And so when I go in there, in order to remotely monitor the surveillance system, they needed at least 1 megabit per second upload speed. It was a low definition surveillance system, but they needed 1 megabit per second. So I go in there and I'm talking to people, and they say, we have a T1 line, 1.5444 megabits per second. And I look at it, I'm like, well, wish you had better than that, but 1.544 means even if somebody's connecting in, that you have more than enough upload speed in order to make that work out. So okay, fine, I'll install it. So I went in there and installed the surveillance system. Everything was working. It worked locally well. It worked great. When we installed it, everybody was home for the day. We had the person remotely in. It worked pretty good. Seemed a little slow, but again, they're on a T1 line. Fucking, it's a little slow. Well, here's the thing. Then I get a call. Get the call during the week, and come to find out, when anybody tries to remotely view the video cameras from off-site, basically the entire internet connection shuts down. Like, everybody in the office can't do anything. I'm like, that doesn't make any sense. You got 1.54 for connection. Again, if you're pulling data from the server, that now is upload speed, and so everybody in the office, they're not doing VPNs because it's the office. They're not pushing data up, so. So yeah, you're using most of the upload speed, but frankly, nobody else should be using upload speed. If you got 1.544, I was like, what the hell's going on? So I go in there and I'm looking at all this stuff, and then I do a speed test, and the speed test only shows me like 700 kilobits per second upload speed without anybody really doing anything. And I scratched my head. I'm like, what the hell is this? Because it's a T1 line. Again, we're not talking about DSL. We're not talking about cable internet or any of that crap. We're T1 line. T1s come with service level agreements. If they say 1.544, that means you are contracted at 1.544. That's the reason people go with T1 lines versus other stuff. But anyway, so I said, it's like, that doesn't make any sense. Again, this isn't Comcast cable. This is a T1 line. Why the hell is it only showing 700 kilobits per second? So then I call up the CEO and goes back and forth. And finally, the IT director, for some reason, who had never communicated with me through this entire process of selling the client the client this thing, that says, oh no, that office has a fractional T1 line. I was like, what the fuck does that mean? And basically a fractional T1 line is where T1 lines are actually 24 channels. And so you don't have to buy all the channels. Every channel is 64 kilobits per second, something like that. So you don't have to buy all of them. All 24 together come out to 1.544, but you can actually buy a smaller amount. And so what they bought is they bought like 768 kilobits per second worth of channels on their T1 line. So they didn't have a full T1 line. They had a fractional T1 line, which, yeah. I'm just going to stop that story before I start swearing again. Saying that turned it into its own problem. But again, I went in there, and that's the thing you have to be thinking about with this converged network is your network infrastructure and your internet service infrastructure going to be able to handle it? Because again, like I say, their network would work fine for what they needed until somebody tried to remotely access that surveillance system. And as soon as they did, internet stopped working, something you have to be thinking about. Then you also have to be thinking about service capacity. So again, we start thinking about things like DNS, we start thinking about DHCP, we start talking about your firewall services, any your router, all of that kind of stuff. One thing to be thinking about is when you start adding these converged devices, surveillance cameras and telephones and all that, that can start putting even more load onto your services. So you may have some just little crappy ass consumer grade router that you've been using for years, right? You have 10 computers in the office. It's been working fine. Well, you have 10 computers in the office. Now you put 10 telephones with those 10 computers. Then you put in 10 surveillance cameras. Then you put in a couple of other things. And all of a sudden, the load on services, DNS, DHCP, all of the routing, that kind of stuff, you've now quadrupled or more overnight. And what you might find out is that little box just isn't good enough. Again, if you're going to be dealing with any kind of real business, this is where you need to be buying business grade equipment, whether it's Cisco or whether it's Netgear even. This is a big thing. If you buy consumer grade equipment and you start dumping 40 or 50 of all these different converged devices onto it, there will be problems. There will be problems. Then the final thing you have to be thinking about in this whole converged world is the criticality of infrastructure. So again, when you think about the normal world with TCP/IP and Ethernet and all that kind of stuff, and basically if one switch goes down in a client-server architecture, what does it matter? Now the secretary is going to scream their head off, and the accountant is going to scream their head off, and the CEO is going to lose their mind. But legally and all that kind of stuff, it doesn't really matter. Basically, these people just need to stop drinking so damn much coffee. You know what I'm saying? Stop drinking coffee. Move to Colorado. Use the legal drugs in Colorado. Stop drinking so much coffee, right? Realistically, if you have a switch go down, most of the time, you're not really dealing with even things like legal issues and all that kind of stuff. But here's the thing: when you start talking about criticality of infrastructure, now you have your telephone systems going through switches. You have your telephone systems going through routers, going through your internet service provider connection. So now, what happens when somebody dials 911 and there ain't no dial tone? And this is something that you have to be thinking about. So with a lot of people, if you have your normal ISP datacom line and you've had that one line for years, and you know what, frankly, it goes out an hour every month, probably don't matter, right? Again, email, whatever, screw it. Users can just get over it, right? So. Well, here's the thing, is do you want to worry that during that 1 hour your ISP goes down every month, that when somebody dials 911 an ambulance isn't going to show up? No, right? So this is where you have to start thinking about things like criticality of your infrastructure, of do you have failover for your network connection? So if you have your Fios connection or whatever from Verizon, maybe it's a good idea to get one of those crappy Comcast lines. It's only going to be an extra $100 a month. If there's a problem, it can fail over to the Comcast line. The other thing to start thinking about is things like mesh networks. What happens if one router or one switch or whatever fails in your infrastructure? Can traffic be automatically rerouted? These are some of the things you have to be thinking about. Basically, again, if a computer or a server can't communicate with the network, right? We kind of gotten used to that. We'll fix it. We'll get to it. Yeah, I know it's a priority. We'll fix it. You start thinking about things like, can somebody dial 911? That is a different way of thinking about your infrastructure. So how reliable it is, how redundant are the systems in it? And this is something that a lot of people don't think about. Now we start talking about convergence. Again, with these issues, with everything coming into one infrastructure, you can have problems. And like real problems. This isn't like Eli being devil's advocate. Eli's just gonna pull problems out of his buttocks just to prove that he's a professional. No, these are actually real problems. You can have real problems when you go over to a converged network. The first issue that I talked about before is the whole bandwidth issue. So if you have your old network infrastructure and you start dumping, 40 times or 4 times or 5 times the amount of devices onto it, you can shut down your network really, really, really quick, even with just simply one incorrectly configured device. If you have a high definition camera that is only supposed to send data when it sees motion, but somebody just checks the wrong checkbox and now it's pumping out high definition data all the time, you can run into problems. You need to be thinking about those bandwidth issues. You need to start thinking about hacking issues. Again, in the old days when you have siloed infrastructure, if somebody's able to penetrate your telephone system, they really can't do anything to your surveillance system or your PCs or your access control. If somebody gets into your PC system, they can't screw with your telephone system or any of that, really. Now, if everything is one-on-one infrastructure, you can have problems with hacking. Basically, you have to start thinking about how are you protecting your telephones? How are you protecting your surveillance cameras? Can your surveillance cameras get hacked? And these are the kinds of things you have to be thinking about. So like with hacking issues, like a big thing now is doing things like updating firmware. Right? So back in the day, if you installed an analog surveillance camera, you didn't have to do anything with it. Right? You put it up on the wall, and as long as it worked, it worked. And if it broke, you replaced it. Like literally, if you had a surveillance camera, the only maintenance was, oh crap, it's broke. Okay, we're going to go buy another one. Like, fixing a surveillance camera was buying another one. Well, now if you've got, 20 or 30 or however many surveillance cameras on your network, one of the questions you have to be thinking about is how are you going to do the firmware updates on all of those cameras? How are you going to do the updates on all of the telephone systems? How are you going to do the updates on the access control systems? This is the type of thing that you have to think about because hackers are looking at it, right? Because everybody is so focused on PCs, right? Windows PCs have been the major security concern for so long that is what people have tunnel vision on. That my only security concern is the Windows PCs. If the Windows PCs are secure, I'm secure. And so what do the hackers do? They go, well, if everybody's worried about Windows PCs, let's try to hack these surveillance cameras. Right? So you're going to have to be thinking about that kind of stuff. Then you also have to start thinking about things like compliance issues. As more and more secure data goes over your network, do you have compliance issues? PCI compliance issues, HIPAA compliance issues, any kind of stuff like that. What are your legal requirements? Because again, when everything is boxed, it's pretty easy to keep that communication secure. Now when everything's going over one network, how are you securing that communication? Is your voice over IP traffic encrypted? I mean, something to be thinking about there, right? You know, if you have a doctor's office and the people in the doctor's office are using voice over IP telephones, is that data encrypted, or can somebody put a little piece of spyware or something on a server and be able to grab all of that voice communication? Again, things that you have to be thinking about. And then finally, you just get to some random issues, just some really stupid random issues. I heard of that. I went to one of these conferences, and one of the speakers there was talking about overheating network cables. So we have convergence now, but one of the things that also with convergence is you can use power over Ethernet. So that's really nice in a converged environment. So now you can run one network cable to your surveillance camera, and you don't even have to worry about running a power cable to it, right? It's just the power goes through the Ethernet cable. One of the things that was brought up is a lot of times when people are running those cable through conduit, they just kind of pack it in, right? You just pack all that in, and who the hell cares? One of the points that was brought up is if you start running a lot of power over Ethernet, power through those Cat5 cables, when you have power, 12 volts of power going through, that's going to heat up all of those cables, right? So data communication doesn't really create a lot of heat, but you're running 12 volts or more, it starts creating heat. So you've got all those cables packed into a little conduit, and then you start heating all that stuff up. All I can say is right? And so again, that's kind of like the random issues that come up. And so if you're going to be going to this converged environment, again, everybody just focuses on the very obvious things. You really have to be thinking about what are the really random issues that can come up. What are the random issues, compliance, all of that kind of stuff. As far as mitigating convergence issues, the biggest thing is just increase your network and your ISP capacity. Again, you go from your 10100 switches to your gigabit switches. Problem solved, right? Solves 99% of the problem. Really is. The beautiful thing, again, for any noobs out there, the beautiful thing about the world of IT is, I swear to you, in our profession is one of the few professions where money really does solve most of the problems. Money really does make our lives better. Here's the deal. I can either run around all day figuring out how to duct tape the system together, or I can go out and buy a really nice gigabit switch, throw it in, and everything works wonderfully. Do remember, for any new people out there, one of the reasons I talk about money so much about our profession is because it really is true. The better equipment you can buy, the more money you spend on the equipment, the better your systems run. Right? If you're going to go over to this converged infrastructure, and when you do, you can build out your old network. You can basically migrate your old network. It just makes life so much easier. So just increasing your network and your ISP capacity goes a long way. Doing quality of service. I did a class, Introduction to Quality of Service, before. So quality of service is where you prioritize packets. Do realize quality of service is a mitigation tool. Mitigation tool is not something that you should rely on. It's one of those things to get you over the bumps of traffic. So something that you can use. Bandwidth throttling, basically restricting the amount of data that can go out of devices. So especially when you start dealing with things like surveillance cameras, any kind of things like that, a lot of times you can actually restrict how much data goes out. So not only do you set what record setting they should be, but also you can say, I only want 200 kilobits to go out per second. So you can do bandwidth throttling. The other thing, and this may seem a little odd. This may seem a little bass-ackwards. But it really is. One of the things you can do is you can create parallel networks. So you've got everything on TCP/IP and Ethernet and DNS and DHCP and all that kind of stuff. Doesn't mean they actually have to be on the same LANs. So some offices, and again, especially as you get bigger, you have more devices on your network. Instead of everything running on the same LAN, the same subnet, you can have your PC subnet You can have your surveillance camera subnet, you can have your access control subnet, and you can have your voice over IP subnet. The benefit to that is you're kind of re-siloing in a way, but you still get the benefits of everything using TCP/IP and doing communication and all that kind of stuff. It's a way of breaking everything apart again, and can be valuable in a larger network. And then the other thing to be thinking about is there's a concept called pushing intelligence to the edge. So this is very important, especially with things like surveillance cameras. So again, surveillance cameras, when they push back data, they push back a lot of data. So you don't want 50 cameras pushing back, 1080p or 5 megapixels or whatever, 24 hours a day. It just doesn't make any sense. So what's really cool with pushing intelligence to the edge is, since you have these new IP surveillance cameras, they actually have little brains in them. They have their little operating systems and all that kind of stuff. And you can actually tell those surveillance cameras what you want to have happen. And then all of the decision making is now in that edge device. So what you say is, I only want to record when there is motion. So in the siloed way, if you said, I only want to record when there's motion, all cameras are sending video back to the DVR, the digital video recorder, 24 hours a day. Then, if there is motion in any one of those feeds, at that point, the DVR decides to record and records that motion. The problem is, in this now converged world, you don't want, 30 cameras or whatever pushing back 5 megapixels 24 hours a day. So you push that intelligence to the edge, and now the cameras themselves know only send video when there is motion. So basically, somebody now walks by, it sees that there's motion, it then records that and sends. So now, instead of 30 cameras sending 24 hours a day, now they're only sending when there is motion. You can actually put a lot of other stuff in there. We'll do a little class on intelligence at the edge. It's really, really, really cool stuff, but it's something to be thinking about. The whole idea of basically how can we not utilize all of the network resources? How can we do this so there's not so much load on our network and the rest of the things? And that's one of the things pushing to the edge does. Final thoughts all the way around. Whatever the hell I may think about convergence, it's here. It's here. Deal with it. Right. Convergence is the way of everything. Everything is going over to a converged world. It is only going to get more converged, as we can see now as we go to the Internet of Things, where literally everything will have an internet device. So that is the ultimate of converged world. As we get into this ultimate of converged world, you're going to have to start thinking about what that means for your infrastructure. How can you deal with it? Again, one of the big problems I see with a lot of network administrators, a lot of systems administrators, is they only focus on known problems. I know that there's a problem, and therefore I will do preventive maintenance to keep that problem from happening. What I want you guys to start doing is thinking about hypothetical problems, right? Hypothetically, what if somebody was able to break into the network? What could they do then? If you design your network around hypothetical problems that you actually haven't even yet seen in the real world, it will be a much stronger network than if all you do is focus on the problems that have been seen in the real world. So basically that's the whole thing, is think about, what if somebody did hack into one of our telephones? If they did, what could happen then? And then if you design your network based on the idea of somebody could hack into a surveillance camera, they could hack into a telephone, or if they could do these things, then your overall network and your infrastructure will be far more robust for when that random thing does happen. They figured out they can hack into print servers. And again, if you're not thinking about it, if you're just focused on my Windows computer, I know my Windows servers are secure. My Windows 10 computers are secure. So I am secure, right? I start thinking about all these other things, Again, if you're packing cables down a conduit, just sit there and think, and you're like, so I just packed 20 network cables into this little conduit. What would happen if I ran 12 volts DC down 20 cables 24 hours a day? Do I think this is a smart idea? And if you think about it, you're like, So electricity is going to heat up the cables. I've got 20 cables in there all packed in. Maybe something as simple as buying a bigger conduit would be a good idea. Maybe I should just double the size of this conduit. Do I know that heating up the cables is going to cause a problem? No, I don't know that. But could it conceivably? Yeah, it could conceivably. And how could you solve this problem before it happens? By spending 25 more cents on a little bit bigger conduit. Right? Is it worth spending 25 cents now versus when things break later? That is the kind of stuff that I would have you thinking about. Again, like things like, now that we're in a converged world, again with things like hacking, just simple things, like really, really, really simple things. Like what happens if a hacker that's outside the building can get up to your surveillance camera, cuts the network cable out of the surveillance camera, reconnects it to a plug, and then literally plugs it into their computer? Seriously. What happens? If somebody did that, would they have complete access to your entire network? I'm betting you a few of you people right now are going, oh, fuck. Oh, crap. Right? This is the kind of thing that you guys got to be thinking about. So basically that's it. The converged world is absolutely awesome as a concept, and it's awesome in real life if you're thinking through all of those problems. And that's really all there is to it. As I say at the end of these videos, do remember I do have other projects. What I found in the YouTube world is people like very specific things on very specific channels. If you try to do different things on one channel, everybody just kind of loses their damn mind. So do realize I have my Failed Normal channel, Failed Normal, where I do my vlogs almost every day. I have the Eli Computer Guy Live channel. That's where I do the question and answer videos. And then if you want to have a meeting with me on Skype, if you go to silicondiscourse.com, I've done like 200 Skype meetings already. Doing pretty good with that. So if you want to talk to me about business, about YouTube, about technology, career development, all that kind of stuff, go to silicondiscourse.com. As you know, as I said before, there are sponsors down in the bottom, down in the description. Click on those links, take a look, sign up, whatever. Again, I don't care if you subscribe. I don't care if you thumb up. I don't care if you comment. Click on those links. And with that, we will leave it with Make YouTube Great Again, Grade A 2016. As always, I enjoyed teaching this class and look forward to seeing you in the next one.